Okay. Early attempt to make an ADA compliant video here. Okay, we're asked to simplify two expressions. I can't just say, here's the expression, I gotta say, and this isn't bad. Okay, first one is the quantity x squared plus x minus 6 divided by the quantity x squared plus x minus 12. Well, that wasn't so bad, was it? Okay, now we factor this. And by trial and error, as we've worked out before, we find that this one is x plus 3 times x minus 2 divided by x plus 4 times x minus 3. So the numerator is x plus 3 times x minus 2. The denominator is x plus 4 times x minus 3. The x plus 3 in the numerator doesn't have an equal factor in the denominator, so it's got to stay there. X minus 2 doesn't have an equal factor in the denominator. The factors are x plus 4 and x minus 3. So x minus 2 has to stay there. So this is done. And we can't simplify this expression. Okay. Next expression is x squared plus 4x plus 4. All divided by x plus 2. And I hope the captions are visible down here. I can see half of my hand. Try not to write too low on the board. It'll take me years to learn this. Okay, now we have this. So we have the quantity x squared plus 4x plus 4 in the numerator, and that factors into x plus 2 quantity squared. We should recognize this as a special product. A plus b quantity squared is a squared plus 2ab plus b squared. If b squared is 4, then b equals 2. And the 2ab would be 2 times 2 times x, okay? A is your x. So this one actually works out. So again, factoring the numerator, we get x plus 2 times x plus 2. The denominator is x plus 2. So this simply equals x plus 2 because the x plus 2 in the denominator divides one of the x plus 2's in the numerator. It doesn't divide them both because once you've divided it into one, it's gone. It leaves you x plus 2. Now, everybody got a pretty good start on factoring these. And most of the class successfully simplified. Some people went a little too far, plugging numbers in for x or whatever. Eventually, that's something we do when we're trying to graph these things. But right now, that's not relevant to simplifying the expression, okay? So we can move on to the topic you have for homework this time. Okay, now just to review just briefly. Again, if we have two fractions like 4/15 plus 3 over 20. Okay, 4/15 plus 3 divided by 20. The denominators factor. 15 is 3 times 5. 20 is 2 times 2 times 5. Okay, now I've factored the denominators. 15 factors as 3 times 5. 15 is the denominator of the first fraction. First fraction is 4/15, so we write that as 4/3 times 5. 20 factors as 2 times 2 times 5. It's easy to factor numbers. You just start dividing by 2. Okay? You divide 20 by 2, you get 10. Then you divide 10 by 2 and you get 2 times 5, right? And similarly with 15, we can start with 2, but 2 isn't going to divide 15, so we try 3. So we understand how to factor numbers. I'm just kind of reviewing that because in a minute, we're going to want to factor some of these polynomials and some of these rational expressions. Okay. Now, again, we've got 4 over 3 times 5. I write that down, and then I leave myself a little space because I'm going to have to multiply that by another fraction to get a common denominator. And then I've got 3 over 2 times 2 times 5. Now, my denominators are 3 times 5 and 2 times 2 times 5. If this denominator 3 times 5 is going to have all its factors in common, or have, okay, if the 3 times 5 and the 2 times 2 times 5 are going to end up with common denominators, what does the 3 times 5 need? It's got the 5, but it needs 2 times 2. So we have 3 times 5, and we multiply that by 2 times 2 over 2 times 2. And now the denominator of the first fraction will be 3 times 5 times 2 times 2. The numerator will be 4 times 2 times 2. Now I've multiplied 4 over 3 times 5 by 2 times 2 over 2 times 2. Okay. That ensures that the denominator will contain this denominator. Okay, so over here, what does this denominator need in order to be common with the denominator we have here? Well, 2 times 2 times 5 has everything that 3 times 5 does, except for the 3. So we've got to multiply this second fraction by 3 times 3. So the numerator will be 3 over 2. Well, we have 3 over 2 times 2 times 5 multiplied by 3 over 3. Multiplying the numerators and denominators out. In the first fraction, we have 4 times 2 times 2 is the numerator, 16. I leave the denominator at 3 times 5 times 2 times 2. Because when I'm done, I'm going to see if the numerator I end up with has any factors common with the denominator. So I want the denominator to stay factored. Whether you understand why or not, keep the denominator factored, and you'll be glad that you did. Okay? And the second fraction, 3 over 2 times 2 times 5, multiplied by 3 over 3 is multiply the numerators, 3 times 3. Multiply the denominators, 2 times 2 times 5 times 3. Now, the denominators are the same. They're not written in quite the same order, but they have all the same factors. If you multiply the two denominators out, 3 times 5 times 2 times 2, you get the same thing as if you multiply 2 times 2 times 5 times 3. All right. Well, then, it actually, when I wrote the numerator of the second equation, it's 3 times 3. I'm going to go ahead and write that as 9 because we know 3 times 3 is 9. This gives us 25 over 3 times 5 times 2 times 2. Now, to complete simplifying this, I'm going to factor 25. Well, 2 doesn't divide 25, and neither does 3, but 5 does. So 5 goes into 25 5 times. 5 times 5 is a numerator. 3 times 5 times 22. I got to have a multiplication there times 2 times 2. Okay, again, we got 16 plus 9 over the common denominator. Common denominator is what it is. 16 and 9 is 25. So we get 25 over the common denominator, which is 3 times 5 times 2 times 2. And if you write that in a different order, it's just fine. Okay. Now, again, we see why we wanted to keep the denominator factors. We've got a 5 in the denominator. We've got a 5 as a factor of the numerator. 5 is a factor of the denominator. It's a factor of the numerator. Some people will say it cancels, and that would actually be correct. But all I'm going to do is say that this 5 in the denominator divides one of the 5s in the numerator, giving you 1. And 1 times everything else is everything else. So this leaves us one of the 5s in the numerator and the 3 times 2 times 2 in the denominator. And that gives us then 5 over 12. Now this illustrates pretty much everything that you need to do to simplify a fraction or a rational expression. You factor the denominators, find least common denominator. Any common denominator is okay, but the least common denominator is a lot less work. Open Math will explain that to you just fine. Do the least common denominator and find out what it is, then multiply each fraction by whatever you need to. Okay? Where what you multiply it by has the same numerator as the denominator, because the numerator has to be the same as the denominator. That way, when you multiply the fraction by the numerator over the denominator, you're just multiplying the fraction by 1. You're not changing its value. Okay, well, you do that, and then you can add the numerators and keep the denominator, and proceed in the obvious manner. You get a numerator over a factored denominator. And then you factor the numerator and see what factors it might have in common with the denominator. So you can divide those out and end up with a result in lowest terms. Now we're going to do that. Add two fractions. And this board over here, right to left, without blocking the picture. Okay, I'm going to take the first fraction we started with, x squared plus x minus 6 over x squared plus x minus 12. And I'm going to add that to x squared plus 16x plus 16. Okay. And that was ignorant. It's going to be x squared plus 8x plus 16. And then that's going to be divided by x squared plus 5x plus 1. Okay, again, first fraction numerator is x squared plus x minus 6. Denominator is x squared plus x minus 12. We add that to the fraction or rational expression. We call these rational expressions when it's not just numbers. It's just numbers, we call them fractions. But it's actually a symbolic fraction. Okay, anyhow, it's x squared plus 8x plus 16. Numerator of the second term. And the denominator is x squared plus 5x plus 1 plus 4. So the denominator of the second one is x squared plus 5x plus 4. Okay, now what do? Just as we did with the numerical fractions, we factored the numerator and denominator. Now, when I did the numerical fractions, I didn't factor the numerator, but I could have. Okay. Turns out, well, in this case, I am going to factor the numerators. Okay, so X squared plus X minus 6 is the numerator of the first fraction, and that factors into X plus 3 times X minus 2. The denominator is X squared plus X minus 12. It factors into X plus 4 times X minus 3. To that, we have the second rational expression. X squared plus 8X plus 16 is X plus 4 quantity squared. X squared plus 5X plus 4 is X plus 4 times X plus 1. And that's, of course, the denominator of the second fraction. So the second fraction, X squared plus 8X plus 16, factors to X plus 4 squared. There's your numerator. X squared plus 5X plus 4 is the same as X plus 4 times X plus 1. And there's your denominator. Now we find the common denominator. Our denominators are X plus 4 times X minus 3 and X plus 4 times X plus 1. And well, the common denominator, the way I often do this is I just write down the first denominator, X plus 4 minus 3. And then I look at the second denominator and see what else I need to contain that denominator. Okay, the second denominator is X plus 4 times X plus 1. I've already got X plus 4 times X minus 3 as part of my common denominator. And I've got the X plus 4 that I need for the second denominator. The only thing I need in addition is the X plus 1. Now my common denominator, X plus 4 times X minus 3 times X plus 1. I need X plus 4 and X minus 3 for the first denominator, and I've got it. I need X plus 4 times X plus 1 for the second denominator. Well, my common denominator is X plus 4 times X minus 3 times X plus 1. I've got the X plus 4 and the X plus 1, so I'm covered. I cover both of these denominators. So now when I do my next step, I'll write my first expression, X plus 3 times X minus 2 over X plus 4 times X minus 3. And what do I have to multiply that by in order to get an equivalent fraction with the denominator X plus 4 times X minus 3 times X plus 1? Well, my fraction already has X plus 4 times X minus 3. We need X plus 1 to get the same denominator, so I have to multiply by X plus 1 over X plus 1. And then my second fraction, or rational expression, is X plus 4 squared over X plus 4 times X plus 1. My common denominator has X plus 4 and X plus 1, but it's also going to need X minus 3. So I multiply the numerator and denominator by X minus 3, my second fraction, my second rational expression. And now we can read the denominators. The denominator of the first fraction in the new form will be X plus 4 times X minus 3 times X plus 1. The denominator of the second fraction will be X plus 4 times X plus 1 times X minus 3. They match. So we have X plus 3 times X minus 2 times X plus 1 plus, again, the numerator of my first fraction was X plus 3 times X minus 2. When I multiplied by X plus 1 over X plus 1, I got another X plus 1. So my numerator of the first fraction is X plus 3 times X minus 2 times X plus 1. Okay, multiplied the second fraction by X minus 3 over X minus 3. My numerator then becomes x plus 4 quantity squared times x minus 3. All that is divided by x plus 4 times x minus 3 times x plus 1, the common denominator. At this point, I can expand the numerator. Well, I'm actually going to do that, but usually I leave that to you. Okay? At this time, I'll expand it. Now, the first term in my numerator is x plus 3 times x minus 2 times x plus 1. Well, that's the same as x squared plus x minus 6 times x plus 1, because the x plus 3 times x minus 2 is just the factored form of the numerator of my original fraction or rational expression, which is x squared plus x minus 6. Okay, so I multiply back the x plus 3 times x minus 2, I get the x squared plus x minus 6, which is multiplied by the x plus 1. The second term of my numerator, when I combine numerators, is x plus 4 quantity squared times x minus 3. Well, that's x squared plus 8x plus 16 times x minus 3. Again, because x plus 4 quantity squared is what I got when I factored the numerator of my original, the numerator of the second term in my original equation, which is x squared plus 8x plus 16. And then that's over x plus 4 times x minus 3 times x plus 1. Now, well, I need to bring this up a little higher on the board. So I'm just going to assert now, if I multiply x plus 1 times x squared plus x minus 6 using the distributive law, I'll have, well, I'm just going to say what I get because we've been over the distributive law. I don't want to explain every step of this. It'll get confusing. If I do this correctly, I get x squared. That's from x times x squared. I'm not going to belabor that. And we're going to get 2x squared. And then we're going to get negative 5x. And then the second fraction is going to give us another x cubed. And then we're going to have 8x squared minus 3x squared, which is 5x squared. And we're going to have negative 24x and 16x, which is negative 8x. And we're going to have minus 48. That's all over x plus 4 times x minus 3 times x plus 1. So using the distributive law, my x squared plus x minus 6 multiplied by x plus 1, I believe, and I'm not going to check, gives me x squared plus 2x cubed. Yeah, I should have changed. I wrote x squared. X cubed plus 2x squared minus 5x minus 6. The second term in the numerator is x squared plus 8x plus 16 multiplied by x minus 3. And if I did that correctly, here's x cubed minus 5x squared minus 8x minus 48. When I combine my terms, in the numerator, I've got x squared plus x squared. That gives me 2x squared. I've got 2x squared and net minus 5x squared, which gives me negative 3x squared. I've got minus 5x and minus 8x, which is negative 13x. And negative 6 minus 48 is minus 54. All that over x plus 4 times x minus 3 times x plus 1. Okay, well, now we could attempt, and it said, I think I said 2x cubed. X cubed plus x cubed gives us 2x cubed, and I wrote down 2x squared. Having written a 2, my hand just naturally wrote a 2. Anyhow, again, the numerator is now 2x cubed minus 3x squared minus 13x minus 54. I can check to see if any of these divide this. Instead of trying to factor this thing, which is probably going to be impossible, I'm going to see if x plus 1 could be a factor. That's easy. If x plus 1 is a factor of this, then if I plug in -1 for x, I'm going to get 0. So I'm going to say that the numerator is not 0. It equals -1. So x plus 1 so x plus 1 isn't a factor of the numerator. Now that's a statement you just want to accept. We don't want to go into that much detail in this course, although it would be appropriate to do so. We don't have time to go into all that detail. Similarly, x minus 3 won't be a factor of the numerator if 3 doesn't make this, substituting x equals 3 doesn't make this 0. So checking x minus 3, I'll say, is x minus 3 a factor? And then I'll say yes or no. If I plug in x equals 3, 2x cubed is 54, which takes care of that negative 54. And then 3x squared is negative 27, but negative 13x is negative 39. So I'll say no to the question, is x minus 3 a factor? I'm going to say no, since x equals 3 doesn't make the numerator 0. Okay, well, the only other term left, or the only other factor left in the denominator is x plus 4. What am I going to do? I'm going to try substituting x equals -4 up here. Okay. Well, if x equals -4, x cubed is -64, 2x cubed is -128, minus 3x squared is going to be minus 48, 128 minus 48, I think is -176. And I've also got a -54, which gets me up to -200 and something. So the negative 13x, even though it's going to be positive, is only going to be plus 52. Now I could plug that into my calculator and stuff, because I don't expect people to be as good at mental arithmetic as I am. Okay, although some people are. And I'm not that great because I do make mistakes all the time, but I can tell from the fact that this is a big negative number, this is a negative number, and this is a pretty big negative number, and this isn't a real big negative number. Okay, in other words, 2x cubed is a big negative number. Negative 3x squared is a big negative number. Negative 54 is a pretty big negative number. Negative 13x, when x equals -4, is the only one that'll be positive, and the negatives are way bigger than the positive. Okay. Bottom line, if you plug x equals -4 in, I'm just going to say, how about x plus 4? And my answer is nope. Okay. And again, you can plug -4 in here. Maybe I should write, let's check x equals -4. We say no. So now I know that my fraction is in lowest terms. And if I wish, I can multiply out the denominator. Okay. Now this all assumes that I did the stuff I did in my head correctly. I think I might have, probably did. But you want to check it. Now that's the complete process of adding two rational expressions. And in this course, the rational expressions will all be second degree polynomials with quadratic factors like x squared plus x minus 6. Stuff you know how to factor pretty easily. Except sometimes I could have, okay, instead of x squared plus x minus 12, I could multiply all those by x. I get x cubed plus x squared minus 12x. Well, you know you can factor out the x. Okay? And you'll see examples of that nature. You want to factor out your monomial first, but by the time you've done all that, you shouldn't have anything of degree higher than a quadratic. Okay? And ax squared plus bx plus c. All right. Well, what about multiplying? Now you'd think addition is easier than multiplication. Not so for these things. Okay? Multiplication is much easier. So let's just try multiplying these same two factors. Yep. Board, yep, good. So let's say we've got x squared plus x minus 6 over x squared plus x minus 12 multiplied by x squared plus 8x plus 16 over x squared plus 5x plus 4. Well, first we factor. We get x squared, we get x plus 4 times x minus 3 again for the numerator of the first fraction. In other words, x squared plus x minus 6 is the numerator of the first fraction. And that factors to x plus 4 times x minus 3. The denominator of the first fraction is x squared plus x minus 12. That's x plus 4. I think I factored that one. Well, it's factoring the numerator. X squared plus x minus 6 factors into x plus 3 times x minus 2. Okay, the denominator, x squared plus x minus 12, factors into x plus 4 times x minus 3. And that's multiplied by x squared plus 8x plus 16, which is x plus 2 quantity squared. The denominator, x squared plus 5x plus 4, the denominator of the second fraction, factors into x plus 4 times x plus 1. And now we simply multiply the numerator of the first fraction by the numerator of the second. It'll be x plus 3 times x minus 2 multiplied by the square of the quantity x plus 2, giving us numerator x plus 3 times x minus 2 times x plus 2 quantity squared divided by product of the denominators. Denominators are x plus 4 times x minus 3 and x plus 4 times x plus 1. If I multiply these out, there's an x plus 4 in both of them, so I'm going to write that just as x plus 4 squared, and then x minus 3 and x plus 1. And okay, now I made a bonehead mistake. The second term was x squared plus 8x plus 16. Okay? I think my eye caught that 4 in the denominator. I said that was x plus 2 squared. It's x plus 4 quantity squared. So the numerator of the second fraction should be x plus 4 quantity squared. And the numerator of the resulting fraction is x plus 3 times x minus 2 times the square of x plus 4, not x plus 2. Now you notice that when I divide these fractions, or when I look at these fractions, I've got an x plus 3 in the numerator. I don't have a factor of x plus 3 in the denominator. I've got a factor of x minus 2 in the numerator. I don't have an x minus 2 factor in the denominator. I've got an x plus 4 squared in the numerator and an x plus 4 squared in the denominator. So I can separate this out. I can write x plus 3 times x minus 2 over x minus 3 times x plus 1. And then I can write that as x plus 4 squared over x plus 4 squared. So I have the rational expression x plus 3 times x minus 2 divided by the denominator x minus 3 times x plus 1 multiplied by x plus 4 quantity squared over x plus 4 quantity squared. We notice that when I multiply out the terms in the numerator, I get x plus 3 times x minus 2 times x plus 4 squared, which is exactly what I had in the previous step. In the denominator, I get x minus 3 times x plus 1 times x plus 4 squared. In the previous step, I had x plus 4 squared times x minus 3 times x plus 1, which is the same thing, just in a different order, and the order of multiplication makes no difference. So now this second factor, x plus 4 squared over x plus 4 squared, is just 1, and multiplying my remaining fraction by 1, this gives me that remaining fraction. I have x plus 3 times x minus 2 over x minus 3 times x plus 1. And now there are no common factors. And I can multiply out the numerator, x plus 3 times x minus 2 turns out to be x squared plus x minus 6. And the denominator, x minus 3 times x plus 1, turns out to be x squared minus 2x plus 1. But that strikes me as a little bit strange. Because the numerator is identical to the numerator of my original first fraction. It's x squared minus 2x minus 3, sorry. Okay, when I multiply out my x minus 3 times x plus 1, I get x squared minus 2x minus 3. That's the denominator of my final fraction. That still doesn't seem right, and I'm gonna pause the video for a second so I can look closely at this. And there's a red flag there. Okay, everyone is off to a good start, factoring. I did make an error. I wrote plus 16 here when I could have written minus 16. With plus 16, you're not gonna be able to factor this. So without going through the details, okay, the first rational expression is x squared plus 10x plus 16. Denominator is x squared minus 6x minus 16. Okay. If you factor it with a plus 16, well, you made a mistake because it doesn't factor, but if it's a minus 16, you can factor it. Okay, the second fraction is x squared plus 5x plus 6 over x squared minus 6x plus 9. Okay, well, the numerator of the first fraction, x squared plus 10x plus 16, factors as x plus 8 times x plus 2. The denominator factors is the denominator is x squared minus 6x minus 16. It factors is x minus 8 times x plus 2. The numerator of the second fraction is x squared plus 5x plus 6. That factors as x plus 3 times x plus 2. The denominator is x squared minus 6x plus 9, which factors as x minus 3 quantity squared if you use the special product, or if you just do it by trial and error, it's x minus 3 times x minus 3, which is the same thing as x minus 3 quantity squared. Okay. Now, one thing we can note is the first fraction has an x plus 2 in the numerator and an x plus 2 in the denominator. So that x plus 2 can be divided out. So I'm going to actually do that. Say that we've got x plus 8 over x minus 8 for the first fraction. Again, we had x plus 8 times x plus 2 over x minus 8 times x plus 2. X plus 2 over x plus 2 is 1. That leaves us x plus 8 times x minus 8. And to that, we add the second fraction, x plus 3 times x plus 2, x minus 3 times x minus 3. Now, our common denominator, our denominators are just x minus 8, and then x minus 3 times x minus 3. What do we need to include both denominators? Well, we certainly need the x minus 8, which is a denominator of first. That time, or a common denominator includes x minus 8. And then it needs a couple of x minus 3s because the denominator of the second fraction has those two x minus 6. You even have the option of writing that as x minus 8 times x minus 3 times x minus 3, or x minus 8 times one of the x minus 3 squared. Now we put everything over common denominator. The first fraction, a rational expression, x plus 8 over x minus 8, only has x minus 8 in its denominator. So we write out x plus 8 over x minus 8. We've got to multiply that by x minus 3 times x minus 3. The denominator has to be multiplied by a couple of x minus 3s. And the numerator's got to match the denominator. Since we're not changing the value of this fraction, fraction we multiply has to be equal to 1. Then the second fraction is x plus 3 times x plus 2 divided by x minus 3 times x minus 3. We have to multiply that by x minus 8 divided by x minus 8. And that's equal to what? Well, it's going to be x plus 8 times x minus 3 times x minus 3 plus the quantity x plus 3 times x plus 2 times x minus 8 in the numerator. That is, the numerator consists of the first numerator added the second numerator. That will then be divided by the common denominator, say, times x minus 3 times x minus 3. Now we're short on time, but as before, we can multiply out the terms in the numerator. And then, in order to determine whether the resulting rational expression reduces, we can check to see if the factor x minus 8 is a factor of the numerator. To do that, we plug in x minus 8 into the numerator. We plug x equals 8 into the numerator and see if we get 0. And then we can check to see if x minus 3 is a factor of the numerator. We plug in x equals 3 and we determine that the first term, as we have it written, would be 0, but the second would. So I believe we're going to find out that get 0 in the numerator. Okay, so we could proceed to then multiply out the whole numerator, put it over the common denominator, and it's then our option, depending on what open math or any other utility wants you to do. Okay, you put the thing into the form it's required. Okay, for my tests, it's fine to keep the denominator active. Okay, but the numerator should be combined. Now, your homework is actually not going to involve any addition, but I wanted to kind of concentrate on addition because if you can do that, it's easy to do multiplication. So the first the assignment you have for next time is just multiplying things. So just factor it, find out common factors, and you've got it. And then this comes just a little later. But everybody did well, at least get a good start on these problems. So I think everybody's going to be okay on this.